Hey folks, welcome to this episode of the Application Security Podcast. This is Chris Romeo, CEO of Security Journey, and I'm flying solo today. I guess I've got the reins, which should be slightly frightening for Robert and anyone else involved with the podcast, but that's okay. We're going to have some fun today. Excited to have Aaron Rinehart join for the second time on the podcast. So he joined way back in season 4 a number of years ago. He and I both had various entrepreneurial journeys happening throughout that since that time. But he talked in those days about chaos engineering and application security. That's what he brought to us. You can go back and listen to that initial episode. But we're here today to catch me up on security chaos engineering. And you as our audience, you're going to get a chance to listen in on this because I've known Aaron for a number of years. I've known what's been happening with chaos engineering and security chaos engineering, and I still don't feel like I could explain it even to a fifth grader. And so I reached out to Aaron. I said, all right, I got to get you back on the podcast because I gotta understand this better. I got to be able to talk about this intelligently. So Aaron, welcome back. And I want to jump right in with my first question. What the heck is security chaos engineering?
Hey, Chris, thanks for having me again. I'm a big fan of what you do, and so thanks for having me on the show. I think, even so, a lot of people struggle with what is chaos engineering sometimes, and I will, so let me explain what chaos engineering is, and I'll explain kind of where security, how it evolved to, or how I kind of evolved it into cybersecurity. Just to give you a background on myself, I've been a builder most of my career, right? Like I'm a builder, I build things, right? And so I was a software engineer for most of my career before I got into security. So you can't really lie to me how things are built, right? I know the process, right? Like it's hard. It's experimentation. It's exploration. You're like, it's a process of trying that worked. That didn't work. That didn't work. That didn't work. Oh, that kind of works. Yay! Right? Like over and over and over again. Right? Anyway, so chaos engineering is it's the technique of proactively, discipline. The discipline of proactively introducing turbulent conditions into a distributed system to try to determine the conditions by which a system or service will fail before it actually fails. So early on in my journey with chaos engineering, I ran into I had a conversation with one of a large payment processing company, and they were talking to me about how they wanted to move their this legacy application that was like the flagship. It did all the payment transactions for the company, and it was legacy. It barely had an outage or an incident. The engineers felt competent. How it worked was well known, and people felt comfortable with the system, right? So I've been through this thought evolution ever since I started with the chaos engineering stuff. Is like to experience this conversation. I started thinking to myself, was that system always stable? Was it always that way, right? I mean, when they first built it, did it never have errors, or outages, or problems, right? Did the engineers always feel like they really understood it and competent? Well, most likely not, right? Because we learn about what we didn't know about how the system really worked through outages, incidents. Those are surprises. If they weren't a surprise, you would have fixed it already, right? You were surprised by that behavior. So you summarize all incidents, outages, and breaches into surprises, right? It's a surprise, right? But those surprises informed us, wow, crap, I didn't know that worked that way, right? Or hell, I'm surprised that ever worked. Right? It tells us, informs us of what we didn't know. And so we learn through a series of outages, right? Incidents, hopefully not breaches, right? That's how we learn. That's how systems become stable. Well, that is a very expensive process. What I mean by that is that it comes at a cost of customer pain or business productivity. Chaos engineering you can think of is a proactive way of accelerating that process where we're not responding to an outage or an incident. Because when people are in an incident, right, they're freaking out, right? If it's a security incident, it's not the security response people that are freaking out. It's everyone else. Like, crap, I knew I shouldn't push that code, right? Or I knew I should have made that change at 3 a.m. whatever, right? Like, and people are worried about the blame, name, shame game, right? I'm worried about being named, blamed, and shamed for being the person that did that caused the demise. So with chaos engineering, we don't do chaos engineering under those pretenses. Chaos engineering is about learning. It's about continuous learning and continuous adaptation. So what we're trying to do is proactively learn about the system through asking it a series of questions. So the series of questions are in the form of, I believe under X conditions, the system is supposed to, I've designed the system to do Y, right? And you never do a chaos experiment you know it's going to fail. There's no, if you already know it's going to fail, you're not going to learn anything, right? It's a waste of time. But what you do a chaos experiment is on what you think you know to be true, okay? And so there's this fundamental first principles problem in all of security that chaos engineering solves. I'm getting to the security pieces I'm helping building here. Mm-hmm. Is that, well, the first principle, it took me a long time to really understand where the value was coming from in what I was doing. And one of the issues is that in modern engineering, what we have this sort of first principles dilemma where, as an engineer, I need the flexibility and convenience to constantly change something. And I'm doing that because the business is asking me to do it because they want to deliver value to the customer in the market, right? So I'm constantly being asked to do that. That's my job, right? But security is a context dependent discipline. And what I mean by that is you have to understand the context of the thing that you need to secure in order to know what needs to be secured about it. And so security is kind of forced into some of a stateful context in order to properly design it. Well, what's happening is that we're in a situation where when we originally designed the security based on the context we had, it was working, right? And then what's happening is that you're constantly getting this curve towards business value, constantly changing and updating and trying to deliver product value to the customer. And then the security is kind of staying with it. And you don't really know, you've kind of diverged from a drift perspective, from a misconfiguration kind of perspective, until there's a problem, right? Or some sort of instrument or error or observable error tells you that there's a problem. Well, it's just a little bit late to do that. So what we're doing fundamentally with security chaos engineering is we're asking the security mechanisms, are you doing what you're supposed to do? And we're not doing it. We're not attacking it. We're not mimicking an adversary. Our goal is not to try to penetrate or get in. Our goal is to proactively verify the security conditions are working. And you can get some of that. Now, the argument can be made with purple teaming or red teaming or pen testing. You kind of are getting that, but it's not necessarily the same goals, right? And the way we do chaos engineering for security is we do one experiment, one failure injection at a time, because we have to be conscious of how we're building systems today, is that we're building these large scale microservice types of environments. I kind of feel like the monolith might have been a good idea at this point, right? Like, it's funny, as I had this thought the other day. It's like, will the monolith live in Hall of Fame of computing like the mainframe is right now? I don't know.
We're going to get back to it, though, because just think about computing in general, right? We went from mainframes to personal computing to cloud, which if you think about it, cloud's just a big mainframe that's happening. So maybe the monolith's going to come back. I mean, we should make some T-shirts and try to bring it back. I don't know. Right?
Bring back the big ball of mud on with it. So there's this problem, right? There's this fundamental first principles problem, right? And what we're doing is we're asking the question, hey, did that thing we designed, does that IAM rule set that you put in AWS still effective against the conditions you designed it for, right? Most likely not. IAM is a target-rich environment. Even if you have the greatest security tools in the world, it's still going to have this problem, right? And that's why I try to tell, even for customers, but hey, it's not that Twistlock, Aqua, Capsulate, whatever are bad. They're not. They're great companies, great products, right? Everybody's got an opinion, okay? But what I'm saying is it's a first principles problem, is that things are changing and there's no feedback loop between the change and the control. The control doesn't know what it's missing, right? We're making many changes today. arguably more than we've ever made before. Just because of the way we're like with microservices, you got a team per microservice. You've got 10 microservices. You've got 100 of each of them running, right? And it's very, very complex and difficult. So this is kind of what we're doing. Okay, we're trying to make the system more stable, trying to correct our understanding of what we believe the system, how we believe the system is actually functioning. So chaos engineering, I want to address this. People also think it's like some kind of like super elitist kind of engineer, like, we can barely do the DevOps or CI/CD. Why can we? I mean, Netflix couldn't do that either. I mean, Netflix was going from a data center to AWS when they developed chaos engineering. They were doing it because there's a lot of unpredictability in what they were building because the cloud providers' AMIs were just disappearing. Like, crap, well, our code, we don't know if our code can survive that kind of failure mode, right? So, like, they tried to design for the failure mode, and then they invented Chaos Monkey to actually exercise the failure mode. And then they decided, okay, we're going to do this constantly and just to ensure that we're ready for this when it happens, because we start streaming to customers and they start experiencing a bad time, they're not going to hang around for $12, $12.99 of subscription. Anyway, so I just want to address that. This is something like that accelerates. The most common driver for chaos engineering is cloud transformation still, and there's a lot of SRE, but like really it's the cloud. So chaos engineering for security. It's really not a whole lot different than chaos engineering. The use cases are a little bit different, and I can explain some of the use cases on where I've gotten value. I'm hearing about other companies out there that are using it in different ways. That's the coolest part of like kind of being at the beginning of something, right? Like one, it started as an idea, right? I was like, I wonder what this looks like, trying chaos engineering and security, because it made sense to me as an engineer. I'm like, oh, well, there's no security system in the system. The system is secure. It's not, right? Like, so it's like you're just exercising the other conditions of the system. I can exercise the security conditions as well, right? And the difference between chaos engineering for security and let's say, so in IAM, IAM and AWS, for example, just give an example. Like, so let's say even if you got Evident.io or you got Evident's gone, but but if you got Palo Alto's tool now or Redlock or whatever you got, that you need to have those tools. Do not hear me incorrectly. You have to have those kind of tools, but like they are reading a config and validating the config. We exercise it, right? And it's interesting enough, we exercise it by introducing the condition that the system is supposed to account for, right? And you would be surprised how often it doesn't account for it. Kubernetes, I'll give an example of Kubernetes experiment, and then I'll get into the origin story of how I started with this. It's a good Kubernetes example. Believe it or not, this is a great example. We found a lot of great results with this at a large telecom, and it's just launching a vulnerable image in a container, right? And the idea is to try to see how long it takes to Splunk, Aqua, whatever solution you have to identify it, detect it, prevent it, block it, whitelist it, blacklist it, whatever it's supposed to do. We have it tuned, configured. And when we originally launched this experiment, I'm like, it's going to catch it all the time. It's not a very valuable thing, right? Like, there's no way, right? I was expecting about 80% of the time to be caught, 20% of the time would be the difference. And, I'm learning actually other people doing the similar experiment at where they work, because if they're having the same results, about 80% of the time it's not even caught, right? Because what happens is you install the tool, right? It gets configured for the environment. And it's hard. Security people, we got to do a lot of stuff, right? A lot of stuff. But recalibration is required, right? It constantly has to be recalibrated to meet the conditions of the system, and we're just not doing that. And we don't know we need to recalibrate because we don't know this problem yet, right? Yeah. And there's drift, right? There is, I'm sure you've been in your career, Chris, in the situation where you brought in the intrusion prevention system or the awesome blacklisting solution, and you get it going and you're excited, and all of a sudden it blocks 60% of all traffic to the flagship application, and they're like, turn that shit off. right?
Yeah.
Like, and then, that happens a lot with security controls too. So like, no, too much overhead. No, because we have to, a lot of times as security people, you and I are engineers by trade, but like not all security people are in an engineering mindset to understand that like, we impact latency, right? We majorly. In a large scale distributed system, the network is already not reliable, right? If you're introducing more problems into that, it just makes it harder and less likely that they're going to keep the security around.
Yeah.
So,
Yeah. Let me ask a couple of clarifying questions too, because like I said, kind of off the top, my goal is to understand security chaos engineering, and so you've helped me. You've kind of laid the foundation for us about the things around it, and so I wanna hit on a couple of things that you said. So it's not pen testing. So what is the difference then between security chaos engineering and pen testing from your perspective as someone who is very entrenched in security chaos engineering?
So, first, just caveat, not caveat, but like put a disclaimer out there. I'm by no means saying pen testing, red teaming, purple teaming, breach attack simulation. I'm not saying any of those things are bad at all.
Yep.
Right? They're still good. They give us good objective. They're instrumentation. They're forms of instrumentation. We need more of that. We need less subjective kind of poor human assessment of a machine. Right? We need an instrument telling us what is happening and give us data to make better decisions. Because engineers don't believe in two things: hope or luck. Okay, so it works or it doesn't, right? And then we fix it. But like. So you could think of security chaos engineering as like security fault injection. You could think of it as fault injection, failure injection. Maybe if that helps you wrap your mind around it, but it's a little more involved than that. But that's kind of like maybe a distinguishing factor for you. And it's not adversarial based, right? It's not. We're not trying to, game the blue team. It's so interesting. A lot of conversations anymore in security, you have to play a word bingo game a little bit. And I feel like, I don't know if you've ever seen I'm writing the new O'Reilly book with Kelly Shortridge right now, and like I'm finding I have to just read it. I have to redefine everything for everybody on everything. It's like there's a security color wheel. I don't know if you've seen that thing before, but it's got like 60 different colors. And like somebody wants to ask me where does security chaos engineering fit on the color wheel? I don't know, pink. Pink testing, green testing, blue. I was like, oh, geez, But anyway. You can think about it as fault injection, failure injection. So we're pen testing. So pen testing is pen testing, red teaming, purple teaming, and breach attack. Well, I'll address breach attack simulation a little differently. But those techniques. So one, red didn't really evolve to purple. Purple became something else, right? And because remember we had this problem with red teaming, kind of like the DevOps problem, dev throwing the results over to ops, vice versa. And we had that problem with red teaming, right? Is that red teams would attack it and they would always have a result and throw to the blue team and say, hey, you suck, go fix it, right? And I'm like, no, I tell you what, you tried doing this job, right? Like it's just not, it was a very toxic kind of approach. And typically red teaming, purple teaming, pen testing is only done on maybe top 5% of all applications. And typically it's either the most highly regulated or it's the flagship kind of core revenue generating kind of applications or products. So the coverage is somewhat poor, and it's somewhat the tools for automation are good, but are good mostly in corporate IT, right? So like when it comes to, because software is a little more dynamic and difficult to address when it comes to automation, because you're dealing with automation, so I'm just framing up some of these pieces. But what I'm saying is all those techniques are still valuable. Don't hear me wrong. Please don't hear me wrong. I know I'm going to get on Twitter and somebody's going to say Aaron was talking shit on red teaming or purple teaming, and I'm not. But like also like we're not trying to like this is more purple teaming and breach and attack simulation. We're not trying to simulate an attack. We're not trying to see the effectiveness of attack, this kind of attack, that kind of attack. What we're trying to do is we're trying to exercise the security like directly.
Yeah,
right?
and that makes sense. I mean, that's I'm somebody who's taken I've taken more of a stand against and so people can send me hate mail or whatever. But I think as an industry, we focus too much on breaking things. I'm sorry, I'm just going to say it. I don't care what anybody. You can get mad at me.
Breaking is
It's
about
fine.
the making. Yeah, but it's about the making. In my opinion, that's where I stand on it.
Yeah, but I mean, you think about how much time, money goes into the breaker kind of side of the world. And so all of that to say, I see the value prop in what you're describing here, though, is because, first of all, to your point, a lot of times pen testing only happens to the top 5% of the apps. What about the other 95%? Oh, no one's ever going to try to attack them. Like, who's making that risk management decision? So I like where you're going in that. I feel like the narrative's leading me towards security chaos engineering is something I can do for the entire fleet, because I'm not paying somebody 40 hours of $500 an hour time to sit for a human being to use tools in their own brain to try to break it. I'm using automation, which I can apply to 100% of my fleet. Am I going down the right path in the narrative here?
Yeah, so let's get more to some of the how, right? So so the first time you ever run an experiment, we call it like the exploration mode, right? So the word is experiment. It should always be experiment, because experimentation is key to all engineering, right? I really dislike that. I don't know who did it in chaos engineering, but they started calling chaos experiments attacks, and I'm like, guys, I was kind of the first security guy on the scene, right? So it's like, guys, security people are gonna hate you for this, right? Like, it was non-security people doing it. I'm like, it's not an attack, guys. It's not an attack. Right? Like, you're not attacking the system. I can show you an attack. It's a little bit different. But anyway, so the how. So the exploration. So the first experiment we write, there are a bunch of different kinds of experiments, but you want to start with something that you just know, hey, without a doubt, or we bought to a SOC, and without a doubt, we know that this is covered, or we think we're covered against a misconfigured port, or a vulnerable image, or a container talking egress out to the internet, or something, right? Like that kind of simple. And the best security chaos experiments, you guys are gonna look at me like I'm crazy, right? Or like that are the low hanging, easy ones to write from a Python or Bash perspective. I mean, like, that's not hard to write this kind of stuff. It's like, but it's like, if you can't handle the basics, you're not going to handle anything more advanced than that, right? People come to Casey and I'd be like, hey, you guys should do some AI, machine learning, it's blockchain. I'm like, no, actually, just the basic, what we're doing is next to no, whether you're Silicon Valley and you're, FANG to anyone else, you can't, no matter whatever engineering prowess you have these problems, right? So once you do, first time you run an experiment, so you write an experiment, let's say a vulnerable image, launching a vulnerable image or a misconfigured port. Well, you write it, you do it, but it's really best done in a game day exercise. Game days were invented by Jesse Robbins at Amazon when he was there. It's not like a red team day or red team game day. It's meant to be an engineering wide kind of perspective, meaning you got somebody from the product team, you got somebody from the call center, right? You got somebody from the response team, somebody from the monitoring team, and maybe somebody from the security monitoring team, and somebody from the IT monitoring or technology monitoring, whatever that team is, or corporate monitoring, because sometimes they're different, right? And what a great opportunity to introduce something all of you believe to be true, and see whether or not it's true. You get such a breakdown of empathy on those game days, but you don't have to do it this heavy human exercise. But there's a lot of value in getting people together that really work together, but they don't know they do, and seeing how the system doesn't, how everyone is wrong, how the system works, and so you don't have to do a game day. You don't have to, right? It's just a good idea to make sure everybody's involved, understands the reasons why you're doing it, and that you're trying to enhance value on all fronts, right? But anyway, so if the experiment succeeds, which it probably will not, you're probably going to be wrong the first time when you run it. I really have never seen a chaos experiment succeed the first time. It's just we're almost always wrong. about how
when you say it succeeds, you mean that the system detected an open port, an unauthorized port. That's success, or is that failure?
That's success. So if it did what it was supposed to do, success, right?
Okay, got it.
That's success. But almost I've never really seen one succeed the first time. I've seen them succeed, but like there's always some kind of recalibration. Oh yeah, crap. You know what? We moved that over a different VLAN, or I don't know. We changed the security group template. I don't know. Whatever it was. You're reminded. Oh crap, we did that because humans, we have a lot of things we have to remember, right? And we have a lot of things in our systems, and it's not easy.
So is there an active agent in this? Let's use the open port example. Okay. So you create a security chaos experiment and you say, I'm going to open a port on this system that should not have that port open. Is there some infrastructure that's doing scanning? Like how do you know whether you passed or failed? Like what systems are giving you the data that lets you determine whether you passed or failed the experiment?
Depends on how you do it. I mean, it really depends on how you set up your experiments. So the majority of chaos experiments really, so Verica is different. I can explain how Verica is different. So we've kind of evolved this craft a little bit, but let me start where everyone else is. A lot of chaos experiments are heavily dependent upon the observability tools you have, meaning like your Splunks, your Hiptio, or not Hiptio, Humio, your whatever you got. And you have to kind of figure out, okay, did it succeed, did it not? One of the best things you can do too is you can hook into what you could do is you could try to hook into Twistlocks API and validate that it caught it. I mean, there's lots of ways you could potentially do that, but a lot of people put it on so you're on the right track. If you want to automate it, that's the path you have to go. Is you have to have something to trigger success or fail, or you're alerting on from some kind of mechanism you put in the in what you wrote to do the experiment. Like ChaoSlingr tracked all the output from. That's the tool. I was going to explain in a minute. Is it tracked all the output and sent it to Slack, right? So it would tell us whether they succeeded or not, and we tracked it there. But if you want to do it and automate it, you want to hook into some kind of KPI with the control. So
are most people doing these manual right now? I'm trying to wrap my mind around this, like as and I know this is kind of a fledgling industry, so there's probably not a lot of people that are like, wow, they're like super mature when it comes to security chaos engineering. But I'm trying to figure out, like, you talked about game days. Is this a manual process where I'm doing a lot of this manually and then I'm validating? Or is there an automated kind of way that I can say, hey, I want to just drop, a lot of different types of experiments randomly throughout the 30 days of the month, and I'm really going to test where we are because nobody's even going to know when they're going to happen?
So unfortunately, from an open source perspective, there's not a lot. And I've been trying to get more people to open source what they've written. I believe Oracle's got a tool for the Oracle Cloud that they wrote. We're going to have a great story about them in the next O'Reilly book, by the way. 10,000. They're doing this stuff on 10,000 endpoints, and it's pretty cool.
Wow, that's scale.
Yeah, it's some serious scale. You have I don't know. I'm not sure how Cardinal Health is doing it. I think they have an automated. I don't know what they use for their KPIs for the experiments, but. ChaoSlingr, how we tracked it was via like the Slack notifying us that it failed, and that would trigger us to go in and look at why and triage it. But I'm not here to pitch my company or the tool, but that's kind of the evolution of what Verica was. It's like Casey and I collectively created chaos engineering as you know it today. Right? He started at Netflix. I expanded it with the security bits, and what we wanted to do was make it valuable for people. I mean, it's not that chaos engineering is not valuable. It's just like people get enamored with the idea of chaos engineering, right? They want to do it, and everyone's saying you got to do it because it's about resilience engineering. It's about stability. Yes, it is, but it can take you all with an open source tool that really is just breaking something and getting to the point of maturity that Netflix had, right? And so what we try to do is accelerate time to value in building that maturity into a tool, right? So Verica, for example, we don't just break something and you have to go look at Honeycomb or whatever to figure out what happened. Our experiments are outcome oriented. We have an observability component that helps inform you like what actually happened, like what did you learn, right? It gives you those insights. So it's built with observations from the beginning, and you can take that kind of approach. And that's but it's just that's kind of how. But even if you did it, even if you did it cron, right? There's a way to do it with write some bash, write some Python, run a cron, even running the experiments once a week or every other day. I mean, like it's not going to be a whole lot of work to really go through that at some point. Like it's informing you, right? That something's wrong. And I see a lot of people hooking in experiments into CI/CD pipelines as well, running because it's really big job scheduler, right? And like Jenkins, but yeah, it's important also to recognize. So it's one of the things that's important is to understand that a lot of people depend too heavily on the CI/CD pieces because a lot of things happen outside of the build process, meaning network configuration changes and environment changes, and you need to. So it's better to continuously run it on its own schedule and inform you than run from CI/CD. But if you want to sort of hack running it at a time, you can put it in a that kind of environment.
Okay. And let the record show I'm about to ask a product related question that I asked and then Aaron's going to answer. So he just, cause I realize Verica, you guys are at the forefront of this world, this new fledgling kind of world of tech. And so from your product's perspective, then when you talked about observability, do you have the ability then to like tap into AWS through some API connection where you're able to then observe any of the actions that are happening? Say I'm using AWS. Like, is that kind of how you're doing observability, or is there something else to it?
Well, it depends on. So the way we approach products is that the way we approach this entirely is. You really hear us even say chaos engineering when you engage with Verica. You really hear like you guys are the chaos people. Yeah, but I'm not trying to give you another thing to do, right? What I'm trying to do is help you with the problem you already have, right? Which is Kubernetes is complicated. AWS IAM is complicated, right? Kafka is hard, right? Because Kafka's number one dependency is the network being reliable. The number one fallacy distributed systems is the network's never going to be reliable. So it's just, so what we do, so we're very narrow and very deep on how we approach experimentation. So that also allows us to look directly at those targeted observations. So experiments are kind of narrow and deep in how they operate, but they're focused on, our experiments are not made up failure modes, right? Meaning they're not like kill pod, kill VM. Netflix had that failure mode in real life, right? So that's why they did that. Now I see all these people, versions of Chaos Monkey for some other system doing the same thing. I mean, yes, but did you actually see that problem, right? Like, so one of the things Verica is also doing is we're trying to create the Internet Incident Library, where it's like we're trying to study how complex technologies and systems fail, right? And what we've been, so that's why Verica was kind of really slow to market. To get to the market is we spent a lot of time trying to understand what are the hard things people are doing now. Kubernetes and Kafka were two of the biggest. AWS is another area, but Kubernetes and Kafka are all both on AWS. But since we take a narrow approach not only to product, because we're trying to help you, keep Kubernetes stable, right, and secure. We're trying to help you keep Kafka the same. You get the idea. It's more of a deeper approach. But when you're opinionated from an engineering perspective like that. It allows you. It makes it easier to observe what happened, what didn't. That makes sense because we know what to look for exactly. So
that makes total sense.
Experiments are kind of experiments are opinionated too. Like if we're assessing resource, allocation in Kubernetes, which is a huge problem in Kubernetes. That's from a normal chaos perspective or stability. We focus on where to go get that information and present it in a visual way. So we really try to present all experiments if we can in a visual, observed way. Because one of the biggest problems, this is why observability is such a big word right now, is that when you have 3,000 microservices, running and all the things and stuff inside of it, it gets really hard to grok information, right? So humans, we need simplification. We need interpretation. We need story. Tell me a story, right? Tell me a story about what's happening. And that's what we try to do. We try to tell you the story, right, about what happened, what we did, right, and what we really learned, how the system's really working. And so I guess if you could take anything from what I'm saying about product, is that these are some tidbits on what you can consider when you design your own experiments.
Yeah, that's helpful. So I want to stop for a second and just say from lifecycle perspective. So I'm a big secure development lifecycle person. How does it apply to Agile? How does it apply to DevOps? I'm always thinking about that. How is secure development lifecycle evolving? Where do you see security chaos engineering in a software development lifecycle and even in the secure development lifecycle? What's the right place that it fits in?
So all chaos engineering in general, whether it's security or not, is post-deployment, right? If the problem is happening post-deployment, it's not that so we still do our smoke tests, our abuse tests, our fuzzing, we're scanning, all these things are still valuable, right? And but where CI sort of forced us to really kind of write smaller bits of code and ship them faster. CD helped us deploy more often. So you can think about it as like building a better engine, right? Is that we built a better engine, right? And then we're able to now go faster. But what chaos engineering does is helps you, we call it continuous verification. It helps you kind of keep and know you're still on the road, right? It helps you identify the safety margin. Well, the one thing in all engineering that you also cannot identify is where is the safety margin? Where is the edge of the system? Because you don't know until you fall off of it, right? It's too late when you fall off of it. That means instant outage, so it's post-deployment. And post-deployment is where the complexity is, right? You got 10 different teams, 10 different microservices. But all microservices are not independent. They're dependent on it. So there's functionality dependent on other functionality. Teams are updating things, and it's very hard to keep track of everything. And post deployment, it's a mess, right? Yeah, you built it, all the tests passed, but the properties we're now expecting from the systems have to be emergent. So I say emergent purposefully, because we're now really dealing with complex adaptive systems, which is a term in applied science. It's where chaos theory comes from. It means that the thing we're working with is no longer linear in cause and effect perspective. It's dynamically nonlinear. What that means is since everything is acting to reacting and changing all the time, you get kind of cascading, magnifying impacts. You get a simple change, can ripple throughout the system and cause harm. So
and there's entropy too, right? There's entropy in a running system like that. Like things are falling apart, the wheels are falling off things. The longer the system continues to run, things are going to degrade over a period of time.
Well, so you mentioned so I wrote an article, probably the best writing I've ever done, hands down. I put on the Verica blog, but it's security differently. And, one of the things I talk about, there's the concept of brittleness. Brittleness in all complex systems can never be zero. You will never prevent all of the incidents and outages. It's just not going to happen. It will not happen flat out. So what you can do is try to increase your ability to adapt and to adapt to change. And that's so if you listen to John Allspaw, David Woods, Richard Cook, that sort of David Woods, creator of resilience engineering, that's what it's all about. Continuous adaptability and empowering the human to be able to adapt and respond. We've all been in those situations where we're like something weird is happening with the system, right? That we didn't kind of expect, and we're kind of having to go to different systems. We're having to respond in ways we haven't responded to before, but we're in the moment, we're doing things that we never thought we'd ever have to do, right? Like, and that's what I mean by capacity, right? So it drives me nuts when people talk about guardrails in security. Guardrails is a no-no word in resilience. It's a no-no word because you design guardrails typically with what you believe to be the system in your head, right? I'm putting this no SSH. I'm putting whatever guardrail protection because you're trying to do the right thing. You're trying to do the right thing. But what happens when you do that is that you think you understand how the system really works, but you really don't. So when a system no longer works that way, your hands are tied. There's an outage. There's an incident. We can't log into it. That's the way we built it. Like we gotta rebuild. Like, you understand what I'm saying? Like, these concepts are really, really valuable, Chris. I mean, like, I've been on really a big journey in diving into cognitive systems engineering, resilience, because I was trying to understand why is this so simple, something so simple producing so much value. And like, I really started getting into resilience engineering and understanding how they got there. And because there was the Netflix people that kind of pointed me towards the resilience engineering stuff. It's not resilience. Cybersecurity people keep saying resilience. It's resilience engineering. That is a completely different field, right? It's a field of its own. Anyway, soapbox off.
So what I want to do is as we're kind of coming towards the conclusion of our conversation here, let's say, imagine, I know this is going to happen with a number of people that listen to this. They're new to this whole idea of security chaos engineering. You've been doing this for a few years now. How would you recommend they get started? Like, if I constrain you to say you can only give them like 3 steps for how they can get started, because I know there's probably a million things they could do, but if you could only choose like, okay, here's the 3 things for somebody, they're brand new, they just heard this, they're like, this sounds really cool. I want to learn more. I want to do some of this. What's the advice you give them?
I would say number 1, read the O'Reilly report. The O'Reilly report will give you greater context on why, how, and how to get started, and like how Capital One built their program, how Cardinal Health built their program. These are not small companies. These are big, complicated businesses that had the need for it and did it. And it was amazing because there is no book for them. Number 2, I would say we didn't talk about ChaoSlingr. ChaoSlingr was the open source tool we wrote at UnitedHealth Group. That it is a ChaoSlingr. It's not the managed project at UnitedHealth Group anymore. It was the first open source tool for the company, but like I left the company and then they use it internally, a different version of it internally. But the point is still out there because people still use it because it's It's more of a framework. There are 3 different functions you need to write. There's the failure injection piece that is Slinger. There is the target acquisition piece, which is generator. What it does is it goes out and identifies which security groups have, for PortSlinger, the main example, it identifies the security groups that have a AWS reference tag of X. Could be, I think we called it, ChaoSlingr was originally called PooSlinger. So I think it was Poo. That's what we used for the tag. Yeah, we're children. And then, and then there was a Tracker, which tracks the output from the experiment and sends it to a Slack channel. But you don't need necessarily, it gives you exactly what you need. It's there in the code. It's not very much code. It gives you exactly the framework by which you have to do it. And you wouldn't be the first people that have done it. People are there've actually been a couple of copies of ChaoSlingr that are out there now that people have been using. So that's 2. Let's see, what would 3 be? 3 be. I'm trying to think of a good 3. Good 3. I don't know. Reach out to me. Now, I have my phone on the internet. I've had it there for over a decade. I have Twitter DMs open. I have my LinkedIn messages open. I am a horrible security privacy person. I do that because I want to make a difference. Right, I really want to make a difference, and no matter how many times I tell people, you can DM me on Twitter, you can email me, you can call me, whatever you want to do. I probably won't answer if you call me because I don't know you, right? But like if you message me that you're going to call me beforehand, I'll answer it. But I have great filtering, so but I will respond. I will reach out. I will be responsive. So I want to help. And I also want to know stories, Chris. That's one thing Kelly and I are really wanting to get right now, is that we're going to collect as many stories as we can for the big O'Reilly book. That's what's being written right now over the next year and a half.
Okay, great. So one kind of last question. So what's your key takeaway for the audience here? Like, now I'm going to limit you to just one. Like, it could be a call to action. You want them to go do something. Maybe it's one of the things off your top 3 list there. Maybe it's just a key takeaway, but what do you want to leave this audience with?
I'm going to leave with. I would honestly say I could say a lot by I hate to say go read a book, right? But we spent a lot of time writing that book. We rewrote it 7 times, so it's meant to be read beginning to end. But read the book. There's it'll a lot of I think you'll find a lot of it evergreen is from a content perspective, in a different way of thinking. And I think that will help you frame up a discussion around, we probably need to look at this. And I will tell you, if I'm leaving with anything, you have no choice. You really, in the end, you will have no choice. Because of the amount of complexity, speed, and scale we're dealing with, chaos engineering is going to be the new normal. It's already becoming that, but it's like people are trying to figure it out. It's still, like you said, fledgling, or people. There are people mature, they're way up here. People in the middle, there's people getting started, right? It's but we don't have enough tools to help us with that post-deployment complexity problem. And chaos engineering is just one of the only ones we have.
Awesome. Well, Aaron, thank you for joining the podcast again. And I feel like now I've got a good understanding of security chaos engineering. I think I've made some connections here in the way you described it. So thank you for sharing that with me, but also with our audience as well. And look forward to catching you at a conference sometime soon as the world continues to open back up. So thank you very much, sir.
Thank you, Chris.